Good evening, one and all present here. This session is part of the NPTEL course on Urban Utilities Planning, Water Supply, Sanitation and Drainage. Dr. Devapratim Pandit is the course instructor, who is an associate professor at the Department of Architecture and Regional Planning, IIT Kharagpur. I am Monica S. I will be your teaching assistant for this live session. I am also a PhD scholar at the same department. We will be going through a few questions that are part of the week 0 assignment set from the previous run of the course to give a basic idea on a few prerequisites or things that you might learn or might have to know about at the onset of the course. Beginning with a very basic question: which of the following is an example of stormwater recharge structure? Vegetated swale, permeable pavements, infiltration basins, all of these. So, what is stormwater? Essentially, that is water that originates from any kind of precipitation, uh, which that is known as stormwater, which includes rainfall, hail, snow, etc. So, vegetated swale is a structure which is basically which some looks something like this. It might have a pipe draining the water that is collected in this depression that we see. It is vegetated and sort of controls runoff or the flow of water, therefore enabling the drainage of water into the ground. The second structure they're talking about, permeable pavements, you must have seen it around a lot of places where instead of paving an entire sidewalk or platform, we have these pavers which have pockets of exposed ground on them so that a bit of rainwater that is collected on the ground can permeate through. We also have these infiltration basins that collect rainwater, make them stand in a place, and then the basin is designed in such a way that it is very permeable to water going in. So I think from the explanation, it is sort of uh, clear that all the three of these can be stormwater recharge structures. So what is a recharge structure? Essentially something that is going to recharge groundwater. The next question: runoff is the quantity of water which flows in sewer pipes, or B due to leakage in pipes, C over land to streams and rivers, or D none of these. So we can see this is from a manual on artificial recharge of groundwater by the government of India. So runoff is essentially defined as the portion of the precipitation that makes its way towards rivers or oceans as surface or subsurface flow. So these are the three types of flows that are included in runoff. So coming from this content, we can conclude that C over land or to streams and rivers is essentially runoff. So coming from that content, which of the following notations for surface runoff is correct? So essentially, that's all the water that is flowing over land to streams and rivers. So when we look at these equations, we realize that C, the total volume of rainfall minus evaporation losses, percolation losses, and transpiration losses. So all the water that is falling on the surface during a spell of rainfall, and then you take away the amount of water that is not going to be running towards a stream or a lake, which would include losses due to evaporation of the water, losses due to water seeping through the ground or percolating through the groundwater, as well as transpiration losses, which is water absorbed by the soil and taken in by the plants or trees, and then the process of transpiration includes these plants and trees letting the water out into the atmosphere again. So the next question: which of the following surfaces has the highest runoff coefficient? Forest and wooded area, parks, lawns and gardens, gravel roads and walks, asphalt pavements in good condition. So essentially, what is runoff coefficient? So we spoke about runoff. Runoff is when the water uh, moves towards streams or lakes or some water body, which is not essentially percolated, or which is absorbed by the soil, or it's evaporated into the atmosphere after falling on the ground. So surface runoff coefficient is essentially calculated as a ratio between the runoff on the surface and the rainfall, the total rainfall that was collected, or that fell on the surface per unit time. So it basically depends on factors affecting runoff. So which surface is more amenable to water moving faster will have a higher runoff coefficient, and the surfaces that are not so good for water running off, which provide a lot of friction or obstacles towards the movement of water, will have a lower runoff coefficient. So these are the usual values of runoff coefficients for typical areas. For an overall urban residential area, we assume the value to be somewhere between zero point 0.3 and zero point 0.5. In case of forests, because of the dense foliage, the plants, as well as the roots taking up a lot of the water that fall on the ground, we have a typical value for runoff coefficient as 0.05 to zero point 0.2. Commercial and industrial areas are usually highly paved, and they usually lack vegetation or anything that will make the water stay and seep through the ground. So therefore, a very high value of zero point 0.9. And parks, farms, pastures have a value of 0.05 to zero point 0.3. And we come to asphalt or concrete pavement, which has a value of 0.85. So amongst these four options that we have, we see that the first three are, first two, due to the presence of plants or vegetation, will have a lower runoff coefficient because they let the water stay for a long time. So the runoff or the movement of water is inhibited. See, gravel roads and walks. So these again, because gravel are more permeable to water because of the nature of the pavement, they will have a slightly lower runoff coefficient than D, asphalt pavements in good condition. So why in good condition? So bad condition asphalt pavements might have these ups and downs, which will enable water to sort of stay there for a long time and collect, and therefore might enable slow movement in a particular direction and then seepage through. Or when there is a gap in the asphalt pavement, it might enable seepage. The next question that we have is urban flood risk management can be achieved by A. Improving operations of dams, B. Increasing the proportions of impervious surfaces in cities, C. Efficient management of groundwater, and D. Improving flood resilience. The thing is, urban flood is essentially attributed to the lack of seepage of water, or the flow of water not into a water body, or into a water body through settlements, which is going to inhibit or damage the property on the way. So the answer would be B. Basically, improving operations of dams will improve risk management. Efficient management of groundwater would improve flood risk management because we are enabling more water to percolate into the ground. Improvement of flood resilience will also improve flood risk management. Essentially, this is settlement having the capacity to bounce back to a previous state is resilience. However, increasing the proportion of impervious surfaces in cities might lead to problems because of increased velocity of water or increased speed of the runoff, which adds to flood risk. The next question. The campaign for water conservation and water security launched in India in 2019 is A. Jal Shakti Abhiyan, B. Swachh Bharat Abhiyan, C. National Water Policy, or D. Nirmal Bharat Abhiyan. So the answer is A, Jal Shakti Abhiyan. It is a time-bound mission mode water conservation campaign under the Department of Drinking Water and Sanitation, Ministry of Jal Shakti, Government of India. There are two phases within this campaign. The first is from July to mid of September, which happens in all the states, and there is a phase two which happens from beginning of October to the end of November, which is in the states which have retreating monsoon. That is Andhra Pradesh, Karnataka, Puducherry, and Tamil Nadu. Excuse me. Sorry about the technical issue. So, continuing with what we were talking about, so the campaign essentially comprises of officers, groundwater experts, and scientists from the Government of India who will work together with the state and district officials in India, most water stressed districts, for water conservation and water resource management by focusing on accelerated implementation of 5 target interventions. So, taking a look at what the other schemes are, Swachh Bharat Abhiyan is essentially a countrywide campaign to eliminate open defecation and improve solid waste management. The national water policy is a policy by the Government of India to govern the planning and development of water resources and their optimum utilization. Nirmal Bharat Abhiyan is a scheme to create awareness among the people about the importance of sanitation, particularly among people from rural areas. So, delving a little more into Jal Shakti Abhiyan. So, these most water stressed districts are essentially districts with critical or overexploited groundwater levels as per the CGWB 2017. For states without these critical or overexploited groundwater levels, districts with the least available groundwater in comparison to the rest of the districts in the state have been selected. So, and there are 5 target interventions that they are looking at: water conservation and rainwater harvesting, renovation of traditional and other water bodies or tanks, reuse and recharge structures, uh, watershed development, and intensive afforestation. These are the 5 major intervention areas under Jal Shakti Abhiyan. Moving on to the next question. What is the per capita water demand for a hostel building according to IS 1172/1993? A 60 LPCD, B 100 LPCD, C 135 LPCD, or D 150 LPCD. So, when we look at this, what is IS 1172/1993? It is an Indian standard code which lays down basic requirements for water supply, drainage, and sanitation. And what is LPCD? That is liters per capita per day. That is liters consumed per person per day for one day. So the answer is 135 LPCD. Let us take a look at the snippet from this code of basic requirements for water supply, drainage, and sanitation, which is IS code 1172/1993. Towards the left, we see the water supply requirements for residences. Usually, it is taken to be a minimum of 70 to 100 liters per head per day. Liters per head per day is comparable to liters per capita per day. So, this requirement, when we calculate the water supply requirement or the water consumption in any city, there we cannot precisely determine as to how much water is actually going to be taken up by every single household or every single individual. So these standards exist for us to be able to sort of generalize as to how much water will be consumed by these households. So, for example, according to the type of community, so communities with a population of up to 20,000 without a flushing system. Mind you, this flushing system is essentially your water WC or the Western closets flush that we have, or a flush water flush that is attached to an Indian toilet as well. So this community doesn't have, most houses doesn't don't have a flushing system. So when the water supply is through a stand post, there has to be a the demand is a minimum of 40 LPCB. Water supply through house service connection, which is connection to every single household, will be 70 to 100 LPCB. For communities with population between 20,000 to 1 lakh, the LPCD is taken to be 100 to 150. For communities with population above 1 lakh, with full flushing system, will be 150 to 200 LPCB. So the standard that we usually take is 135 LPCD whenever we are working out, or when no other givens or details are given, and we know the city to be more than 20,000 in population, we take it to be 135 LPCD. Towards the right, we see water requirements for buildings other than residences. So, which includes factories where bathrooms are required to be provided, will have 45 liters LPCD. Factories where no bathrooms are required to be provided will have 30 LPCD, uh, and so on and so forth. We can see that hostels have a requirement of 135 LPCD. These codes are available for download from standards bis.bsbedge.com, and you will have to log in and with your credentials, and you can download a free copy of the PDF from this website. Moving on to the next question. Which factor does not affect per capita water demand in a given area? So we just saw the BIS standards for water requirements. So A. Climatic conditions. B. Population size of the area. C. Lifestyle. And D. Material of pipelines. So climatic conditions will affect water demand in per capita water demand in a given area, mostly because, say, the area is a very hot and dry climatic area, we will end up using a lot of water to sort of humidify the area. So which means water consumption would increase. Say population size of the area, as we had just seen, uh, population less than 20,000 would, we will cater to a smaller LPCD. Population more than 20,000 will have a higher LPCD. Why is that the case? Basically, there is a minimum amount of water consumption per city, no matter what the size of the city is. In other fields, we may call it fixed cost. So there is going to be a basic amount of usage that the city takes up, and when we are, say, calculating the water consumption or the water demand for an entire city, what we do is we do not take the number of shops, the number of theaters, hospitals, etc. Um, separately. What we do is we take the total population of the entire city, and we sort of multiply it with the per capita or the LPCD value that we have. So in order to account for this basic amount of requirement, the city will require a few basic facilities, such as hospitals or infrastructure requirements, which are going to be there no matter what the size of the city is. Of course, with the size of the city increasing, we might see an increase in that demand as well, which is why there is an increasing LPCD calculation or amount given here as well. So, yes, population size of the area does affect water demand in a given area. Lifestyle of the population, again, as something as simple as whether we use flushes or a flushing system in our toilets, will change the way the city demands water. There, some societies might be very conserving in their behavior by their very nature, excuse me, and some societies might not be so judicious in their water use. So option D, material of pipelines, is the answer, because this does not really affect water demand. It might affect water supply, but not the demand side of things. Moving on to the next question. Water supply services in an urban area does not cover A. Collection and treatment of water, B. Distribution of water to consumers, C. Provision of hydrants for firefighting, or D. Provision of sprinklers in buildings. So, water supply services in an urban area as a collective will not be looking at provision of sprinklers in buildings. So, that is essentially the purview of the individual or the individual household. It what it will come under will be the distribution of water to consumers. The consumer will be provided with an amount of water, or with water supply essentially, and the provision of sprinklers within the building will be under the purview of the um, individual or the organization that the building belongs to. In fact, fire hydrants which are going to be there on street will be provided by the government. Moving on to the next question. What is an aquifer? A body of saturated rock or soil through which water can easily move. B. Underground rivers or lakes. C. Geological formation found on the surface. D. None of these. So the answer is A. It is basically a body of saturated rock or soil through which water can easily move. So we can look at the two major types of aquifers here. One is the unconfined aquifer, which is where we get most of our groundwater supply from. So don't be mistaken from the diagram. So this blue part is also rock or soil, which is permeable enough for the movement of water, and it's not a layer of water per se. And then the confining bed is basically a layer of rock which is impervious to water. It might have certain channels of infiltration or cracks where water might move through, but in general the bed is impervious to water. And then confined aquifer is essentially an aquifer between two such confining beds or impervious layers of water. The next question. Underground water sources include A. Spring, B. Wells, C. Infiltration wells, and D. All of the above. So the answer is all of the above. So this diagram basically shows how each of these are formed. So spring is basically a break in the surface uh, which is below the water table, below the level of water table. Therefore, water starts pouring in. Infiltration wells are wells at the bank of or very close to the bank of the river, which need not necessarily actually go into the water body itself, but uh, it can be at the bank of the river and letting in the absorption of water. The other structure is the standard well that we have. All of these are underground water sources. The next question. Economic height of a dam is the height corresponding to which? A. Cost of the dam per unit of storage is minimum. B. Amount of silting is less. C. Cost of dam per unit storage is maximum. D. Free board provided is least. So the answer is cost of the dam per unit of storage is minimum. So as we can see, economic height, from the term economic, we see that the height is we are looking at the economic efficiency or trying to attain the most economy out of the construction. So when we have any dam with increase in dam height, there is going to be an increase in cost of construction. However, cost per unit storage of water, initially the cost will be dipping, it will reach a minimum, and there will be a point beyond which the cost per unit storage will again rise. So this lowest point where we have minimum cost per unit storage of water, The height of the dam at which this can be achieved is the economic height of the dam. Excuse me. Moving on to the next question. Service level benchmarking for water supply services in India is given by a Central Public Health and Environmental Engineering Organization CPHEEO under the Ministry of Housing and Urban Affairs, B. Central Public Works Department, C. National Building Code of India, D. State Public Works Department. So, what is this service level benchmarking? It is basically a tool for performance management and accountability in service delivery by the ULBs, and it involves the measuring and monitoring of service provider performance on a systematic and continuous basis. So whenever there is a provision of any service by an organization, so in case of water supply or most urban infrastructure, it could be either the urban local body, or say in case of transportation it could be a particular special purpose vehicle or a department under the central government, say in case of railways or a metro. So what happens is, when there is this service provision by a government body, how do we figure out whether the service provision is adequate enough, or is it, how much is the service, how efficient is the service? In order to figure out the level of service and to maintain a standard in the level of service, we do something called benchmarking. So there is a minimum level of, there is a minimum level of service that needs to be provided by this uh, body. Say in case of water, the water supply is going to be provided by urban local bodies predominantly. So we mark a minimum level beyond which it is considered to be good service provision. So in India, the service level benchmarking for water supply services is done by CPHEEO. So they have this handbook of service level benchmarking. It is a ready reckoner to enable ULBs and other city level parastatal agencies to implement systems for measuring, reporting, and monitoring the SLBs. So it's not enough that the benchmark is set, but the agency should also be informed as to how do you calculate this benchmark, how do you report, or how do you monitor the constituents of this benchmark. So let us take a cursory look at what this benchmark is. So this handbook of service level benchmarking by CPHEEO, it provides four major sets of benchmarks. One is for water supply services, second for sewage management or sewerage and sanitation. Third is for solid waste management, which is not the part of the purview of this course. However, it is being provided by CPHEO as well as stormwater drainage. So under each of these, say water supply services, we have 9 indicators which are calculated to sort of determine how much is the level of service in a particular urban local body. So what happens is, so say we'll take the example of coverage of water supply connections to see how this SLB works. So for each proposed indicator, the handbook gives the following details. So it gives a definition of the indicator, the data requirements for computing the indicator, calculation of the indicator, rationale for the indicator, why is the indicator part of the calculation of the SLB, reliability of measurement as well as level of measurement. So taking this example, so we can see here a definition of the first indicator. So under coverage of water supply connections, we have under water supply services, we have coverage of water supply connections, which corresponds to household level coverage of direct water supply connections. So it is measured as a percentage, and they've defined it as the total number of households in the service area that are connected to the water supply network with direct service connections as a percentage of the total number of households in that service area. So service area implies a specific jurisdiction in which service is required to be provided. So then they talk about data requirements. What are the data that the, say, urban local body needs to know in order to be able to calculate this indicator? So in case of this coverage of water supply connections, we have one, total number of households in the service area, and two, total number of households with direct water supply connection. And then this is the formula for calculating the indicator. So household coverage for water supply connections uh, as a percentage will be B, which is the total number of households with direct water supply connection, divided by A, total number of households in the service area, into 100. So this percentage, say a particular urban local body, it comes out to be 78% when they've calculated. So, but how much? So first of all, let me go a little. If the urban local body is actually coming out to be 78%, the benchmark set by the government or CPHEO is 100%. So they are giving no excuses. Any urban local body which is supplying water should be able to reach all the houses in its service area, no matter what. So that is the benchmark we set. That being said, so what will happen is we can issue this number, this indicator, as an indicator for them for for the scope of improvement, or how much should they improve, or how much is deficient. So SLB sort of help in assessing how much the deficiency is. Um, the handbook also gives the rationale for the indicator as to why the indicator is included in the estimation. The reliability of measurement. So what happens is data availability in different urban local bodies or different agencies, parastatal agencies, might be very different. So for example, in case of water supply connections, the highest preferred level of reliability is when you have the actual number of households with direct service connections. So you have a complete enumeration of how many households are there in the service area, as well as how many households have connections. However, say this is not available, then we can move one step lower. So estimation of households covered computed as the total number of connections for which data are maintained as a percentage of the estimated number of households on the basis of population. So we do not have the total number of households in the city, but the urban local body has a record of how many houses have the connection. So what we do is we can calculate the total number of households on the basis of population. So in case of, for most Indian cities, the number is taken to be 5 for average household size. But however, depending on the size of the city, it could be 4.5, 5.5. It depends on again the city under consideration or the service area under consideration. The one level down of reliability of measurement would be we don't have the number of houses that have water supply connections as well as the number of houses that are there. So we estimate the number of households covered on the basis of road length. So say so many meters. So say you've calculated 100 meters of road length, so many houses are taken to be a proxy. So as a in a very dense area, say 10 meters, you have two houses, or 20 meters, you have two houses. So you take that as a surrogate indicator for the number of households, and therefore for the indicator as well. So such level of reliability is what makes this SLB very robust, because we know what kind of data has been used to calculate the ratio. The handbook also prescribes a level of measurement, which is the time period in which this measurement needs to be done, as well as what is the level or jurisdiction or the areal unit across which the measurement needs to be done. So that is a gist of how service level benchmarking is done in India. Moving on to the next question. The amount of oxygen consumed by the aerobic bacteria which cause the aerobic biological decomposition of sewage is known as A. Biological oxygen demand, BOD. B. Dissolved oxygen, DO. C. Chemical oxygen demand, COD, or none of these. So the answer is biological oxygen demand. Uh, Chemical oxygen demand is the amount of oxygen required to break down the organic material via oxidation, so through chemicals. Whereas BOD, or biochemical oxygen demand, or biological oxygen demand, is the amount of oxygen required by the microorganisms to break down the organic materials. The option B, dissolved oxygen, is basically the amount of oxygen that is present in water. Moving on to the next question. Corrosion of a pipe, the pipeline that is carrying water. A. Reduces its lifespan. B. Reduces its carrying capacity. C. Adds color and odor to water. And D. All of these. The answer is all of these. So when corrosion happens, the pipe essentially gets damaged and is prone to breakage or some form of leakage. And above all, corrosion also means that some chemical or metal from the pipe sort of gets mixed to the water, which leads to color, as well as the possibility of leakage could also cause color and odor to water. Moving on to the next question. Hardness of water is due to A. Sulfates of heavy metals, B. Aldehydes, C. Calcium and magnesium salts of higher fatty acids, or D. Sodium salts. So hardness is essentially defined as calcium and magnesium salts of higher fatty acids. So the impact of hardness is that um, like domestically, when we talk about it, we talk about how the frothing when we use water is lower when water is harder, or that is basically considered to be an indicator of hardness of water. However, the long term issue is that it can lead to scaling, which is addition of layers within the pipe, which can reduce the capacity of the carrying capacity of the pipe. So this is from Indian Standard Code 10500 2012. So there is a list of general parameters concerning substances undesirable in excessive amounts within water. We can see that total hardness is essentially considered as calcium carbonate. So we can see that calcium and magnesium salts of higher fatty acids. That's how hardness is defined. Moving on to the next question. The septic tanks are designed to A. Hold sanitary sewage for some time so that it is partially digested. B. To exclude oil and grease from sewage. C. Allow water to soak in the ground. And D. Treat grit and sand. So the answer is A. Hold sanitary sewage for some time so that it is partially digested. Um, we can see a typical cross section of a septic tank in here. Although exclusion of oil and grease does end up happening when we are using a septic tank to connect to mm, say an outlet. However, that's not the primary purpose for which it is designed. Moving on to the next question. Treated wastewater from sewage treatment plants can be used for A. Agriculture and horticulture, B. Industrial use, C. Large scale construction activity, or D. All of these. So the answer is all of these. However, when we are using it for industrial use or large scale construction activity, we need to ensure that the treated water meets the chemical and biological standards required for such use. Thank you, one and all, for your time and attention. I hope this section was useful for you.